And last but not least, we have Jim from Attestant. Jim, whenever you're ready, feel free to share your screen and you can get started.
Yeah, screen sharing is optimistic. I'm just going to talk, I'm afraid.
All right, that works too.
No slides, no slides. So there we go. Okay, yeah. So really want to just to have a brief overview of what is coming in the next major release of Vouch. So for those of you who are unaware, Vouch is a validator client. It is designed to work with all of the major consensus nodes and designed to offer features that allows certainly for large node operators, but also for smaller node operators to have a little bit more safety, security, and performance in and around their validating. So the first thing that comes with the next release of Vouch is obviously going to be support for DNAB. So we expect this release to come out finally over the next week or two. We're really just waiting for the consensus specs to be finalized, just make sure there are no last minute changes. As soon as they're locked down, we'll release this version. So DNAB support means that will carry us through the next hard fork all the way up until what will eventually be Electra. So that's a good time for us to look at an update and make some minor tweaks. One of the other things that came in relatively recently was the launch of the Husky testnet. Now, that testnet was a little bit different from most of the other testnets we've done in the past in that it started off with over 1.4 million validators running on it. That caused various stresses and strains in all clients, all implementations and similar. And it allowed us to take a little look at some of the features that we provide at the moment and some of the places where we potentially provide a little bit of optimization. So there are some optimizations going in around reduced connections to beacon nodes. We're reducing the number of connections going to each individual beacon node. That reduces memory. We have some significant reductions in both CPU and memory usage again as the number of validators increases. And that's very important because obviously one of the things we need to do is make sure that this validator client remains as efficient as possible. One of the other things that we've been looking at is to understand how our product impacts other people's products. So one of the areas where that came up was looking at validator registration. So one of the parts of talking to MEV relays is that we have to send them a registration for each validator saying what it is, its gas limit, its sphere recipient, and similar. That was all kicking off at the same time. So at a certain point in time within an epoch, every single Vouch installation across the planet would send its data back to the MEV relays. Obviously, that's not great for them. It can cause them to overload slightly. It can certainly slow things down, potentially get in the way of other people trying to create registrations and similar. So one of the things we've done there is we've now started to spread that out. So that information is now spread out. It's picked basically a random time somewhere in the middle 80% of the epoch prior to the one where it matters. We will send all the validator registrations. That means regardless of how many vouchers are running around the planet, we'll be in a situation where the load on the validator, sorry, the MEV relays themselves should be much, much less. Still sticking with MEV relays, one of the features that MEV Boost has is the ability to try to unblind blocks, to go and fetch the unblinded block from all relays that it knows about. So when we fetch a header from an MEV relay, we'll get information about the best block it has. And that will leave us with a list of MEV relays that know about the best block. Now, traditionally, what we did is we went back and we fetched the block that we wanted from only those relays. However, due to the way that the relays work, it's possible that that same block had been passed around in the background whilst we were doing our work of signing and composing the consensus block. And as a result, there are more nodes out there that have that block than we originally knew about. So there's an option in Vouch coming in the next release to say what we can do is we can go and talk to every MEV relay regardless of if it said it had the block or not. That allows us then to have the best possible chance of returning the block. The reason it is an option rather than just a default is because it does have a downside, and that downside is that it will create noise and errors in a log. If we go to talk to a relay and it doesn't know anything about the block, it will spit out an error. that error will show up in logs, but it'll also show up in our metrics. So rather than enforce that and potentially have people who are monitoring through Prometheus start to get lots of errors, we've made that optional, but it is there and it's available in the docs. The other big piece that is probably the most interesting, given what's happened recently, is that we've also added in a new attestation data strategy. So if you'll give me 2 minutes just to go back and talk about the sort of supermajority issue we're seeing at the moment on the execution side with Geth. I'm going to assume you understand what the problem is. However, what I'd like to say is the problem is not about Geth proposing a bad block. Any consensus, excuse me, any execution node can propose a bad block. We expect that to happen. But what we want is for all of the other execution nodes to then reject that block. What that means is what we actually care about is not if a block has been created correctly, validly or not, because most of the time we can't tell that. What we care about is if the other execution nodes have accepted that block, if they have independently validated that block. So what we can do today in Vouch, and for those of you running Vouch and having Geth in your environment, I strongly recommend you do this. You can set a list of nodes from which you will obtain attestation data. And that list of nodes can be all of your nodes minus those running Geth. What that means, so let's take a simple example. Let's say you have two setups. So you've got 2 execution clients. One is Geth, one is Nethermind. When you come to obtain attestation data, if you fetch it from Geth, Geth could have imported a block that another Geth made. Bear in mind, it doesn't have to be our local block, our local instance that proposed the block. It could be any instance that proposed the block. But if Geth has imported that block and considers it valid, even though it is not valid according to the spec, then it will give us an attestation that includes that block on chain. If we go to Nethermind and we ask it for an attestation, if it has attempted to import that block from Geth, seen it is invalid according to the specs and rejected it, the attestation will be for a chain that does not include that block. So ultimately what we're trying to do is not remove Geth from our environment. It's very, very important. Geth gives us lots of good things. It's a highly performant system. It runs well. It generates good blocks if you're obtaining local execution payloads. A lot of people use it for additional purposes. They'll use it as an RPC node or similar. And ultimately, if our current campaign out there is highly successful, Geth may well become a minority client and something else may become a majority client. In which case we'll be in exactly the same situation, but just, Geth being replaced by Nethermind or Bess or whatever it might be. So it's important to retain that flexibility of being able to move from one to another, being able to say, okay, now, new client is super majority. So actually we can't ask that for attestations. So today you can take a very simple approach and you can just turn around and you can say, okay, great. I'm running 2 different execution nodes. I'm just going to ask Nethermind for my attestation data, all happy, forget Geth, not a problem. That works fine and that works well. However, if you then consider more complex scenarios, then actually what you may want to have is agreement between nodes. So rather than just shutting a node out, maybe what we want is we want to make sure that multiple different execution clients all agree on the correct attestation data to provide the correct chain to attest to. So there's a new attestation strategy going in called majority. A majority does very much what it says on the tin. It will obtain attestation data from all of the connected execution clients. And what it'll take is the one that has the majority of votes. If we've got, say, 3 different nodes out there and 2 of the attestations match and one of them doesn't, we'll take the 2 that match. What we can also do is we can supply a threshold. So if we take, a larger example, let's say there are 4 different four different consensus nodes out there, and we get a combination where maybe it's 2 and 1 and 1. We can get to the point where there's broad disagreement on which particular attestations we should pick. Now, ultimately, and this is again, as with many things in Vouch, it's a strategy and it's there as an option. And the reason it's there as an option is because it really comes down to how you, as a node operator, would like to react in different situations on the network. So in this case, we're looking at a situation where potentially only 2 of the nodes agree, or none of the nodes agree. And the question is, what do you want to do then? Well, you could just pick whichever attestation data you wanted, or you could say that at this point in time, we believe the network is in an unstable state. So we're not willing to attest to anything. Now, yes, that will create a situation where potentially you're going to take a minor loss in your validator because you're not attesting to anything. But equally, it may be important to you that in a situation where the network is unstable, where you cannot get any agreement from your nodes, that you don't attest to anything, that you play safe, that you make sure that you have a certain threshold you have to meet in terms of agreeing nodes before you proceed. So the majority attestation data strategy also has within it the concept of a simple threshold. So you might be the majority. You might have managed to get 2 of your 4 nodes to agree, but your threshold might be 3 of the 4 nodes. You might want to actually have a higher level of agreement, in which case, even though you've got 2 of the 4 nodes agreeing and the other 2 disagree, it's still not enough to meet the threshold. It's still not enough to create an attestation. As said, there are lots and lots of different ways of looking at these things. There is no simple single answer, because a strategy that works well in one particular situation may not play as well in a different one. You know, you can have actual chain splits. We can have network outages. We can just have nodes that for whatever reason lose a lot of their pairs, and so they have a slightly different view of the network. There are lots of different things out there that can happen, but it's very, very important to make sure that what we try and do is ensure that we have the best option available according to your own preferences. So there are lots of other minor little bits and pieces going into the next release of Vouch, but they are probably the major ones out there. I'm happy to take any questions on Vouch if people are interested, the current version, the new version coming out, or just more generally.
I'd like to ask some questions around the attestation strategy. So let's take the simple example that you mentioned in the beginning, which based on your response on the forums is also the strategy that you're currently using for the validators that Attestant BVI is running as a part of the Lido protocol, whereby geth is not used to validate execution layer blocks. So what happens if your own nodes, your own validators, propose blocks that are proposed by geth, or as the case is very likely proposed via MEV boost, so almost certainly proposed by geth because most builders use geth. Is there a possibility that your own nodes will end up not attesting for these blocks if the execution layer that you have that's providing that the validity of the attestations is in disagreement?
Absolutely. So proposing and attesting, if you want to think of it, are 2 completely different phases. So regardless of who proposes a block, where it comes from, MEV relays are a good example. You know, we can't do any validation of this before we actually sign the thing. So we are very much signing blind. That block is then sent out on the network. Now, regardless of who proposed it, if we assume it was generated by a geth or geth similar execution node and is not imported by the other execution node, so say, you know, Besu doesn't like it, Nethermind doesn't like it, then we'll end up in a situation where geth thinks, let's say, you know, block 7, which is our block that's just been proposed, is the current head, but Nethermind and Besu will think block 6 is the current head because they looked at block 7, they failed validation on it, and so they threw it out. So what we want to do then is we go back and we say, okay, well, when we're going to get attestation data, we'll talk to the consensus nodes connected to Nethermind Besu, basically not Geth. And that will give us block 6 as the current head of the chain, and we will attest to that. Now, that's all fine. And the common question is, well, what happens the other way around? What happens if it's Nethermind that's got the bug and it creates a bad block when it imports a bad block? Well, the answer is we will attest to the bad block. But because Nethermind is not a supermajority, we will not cause the chain to split. We will not cause a finalization issue. What will happen is purely that they'll look at our head vote and go, nah, wrong. And as a result of that, our attestation will lose a small amount of money. But obviously, this is now in a situation where we actually have bad blocks being produced and we're still gaining the majority of the funds. Our source vote will be correct. Our target vote will be correct. And so we're actually okay, and we'll keep going. Now, over time, that will decay. We will lose target vote as we lose finalization on the chain, but we will only lose that locally. And again, there will be no long-lasting impact to the chain. And again, once that is fixed, then we will come back up and we will carry on attesting normally. So certainly, when we consider the impact of a bad block, we should consider the impact of a bad block being produced by a non-supermajority client, of being accepted by a non-supermajority client. And in fact, that's exactly the situation that we saw, where there was a split between Nethermind, where it decided certain blocks were invalid or not, and the rest of the network where it decided certain blocks were invalid or not. But Nethermind does not have enough percentage of validators behind it to impact the chain. It would need to be at least a third for the chain to stop finalizing, at least 2/3 for invalid chain to finalize, and that hasn't happened. Now, ideally, we'll get to a stage where we have 4 execution nodes with 25% each, 5 execution nodes with 20% each of the network, and then everything will be calm and easy, and the only potential impact is to local validators themselves. Until we get there, we need to be a little bit more careful about the nodes to which we listen to understand the head of the chain. And we should always go with the minority nodes, because even if they're wrong, the impact on the chain overall and us as validators and node operators is much reduced.
That's a really, really great tutorial on attestation and validity. There's a small kind of implied assumption here, which for now probably isn't very key, but eventually may be interesting to think about. And that's that each client is kind of isolated and independent in its interpretation of the spec. But it's theoretically possible that 2 clients together who would comprise a supermajority, or hopefully not, but maybe just a majority, may have the same, let's say, incorrect interpretation of the spec. Or you might have 4 clients all at 25%, and 2 have the same interpretation of the spec, and the other 2 have the same interpretation of the spec. In cases like that, how do you go about determining what's actually the canonical chain?
So if we take a simple example, then that last example you gave, let's say we have 4 clients and each has 25% of the network. The great news there is that if 2 go one way and 2 go another, all we end up with is a non-finalizing chain. So we're in luck. What happens is the client teams will have to sit down, work out which ones are correct and which ones aren't, patch the clients that are not, and then bring them back online. When they bring them back online, we will immediately get back to a situation where we can then finalize at the next epoch or the 2 epochs down the line. So it's one of those situations where, and everyone worries about the supermajority, and they absolutely should, but ideally we want to get everything down so that if 2 clients have a different view, we'll still be in a situation where the worst we have is a non-finalizing chain. Now, look, the reality is, unless we have at least 6 different clients and they are all having an equal share, we're always going to be in a situation where if 2 clients disagree, then we hit some kind of issue. But realistically, if we can keep the percentages fair and even, then that issue will be a lack of finality rather than finalizing an invalid chain. So in terms of, internally, how would Vouch choose? Well, it depends what it's talking to. As we talked about with the majority system, potentially you could set it up so it won't. It could just refuse to attest to anything. Now that's playing it safe. It's losing a little bit of money, but it's only a little bit of money compared to what you could lose if you finalized on the wrong chain. And again, one of the things that is very important to understand, and one of the reasons Vouch has all this in configuration rather than hard coding anything about Geth, is because, as we have seen on the consensus side, the mix of clients can change. New clients come up. Existing clients that are dominant might come down a bit, either because people are worried about them being dominant and having a supermajority, or because other clients fill a hole. We have, when we look back at a few years back now, when Prism had a supermajority on the consensus side, we started seeing clients like Nimbus come up, much lower resource utilization. So there wasn't just a case of move off the supermajority client, it is bad for you, because as we've seen, it's a relatively tough message to get across. But for people who are coming on board and going, well, actually, Nimbus looks like a great option. It's got much lower resource usage. I can put it on a smaller box. I can save myself money. There was a natural move to it. So as long as we can keep those clients flowing, as long as we can see that happen, then that's going to help us. And we may see over time that once dominant clients become less dominant and become absolutely subservient to a new dominant client. So we might find that actually the percentages change. And if that kind of thing happens, then we're in a situation where we've got the same problem, but it's not Geth anymore, it's Nethermind or whatever else, right? So it changes around. So we need to make sure that we have the flexibility to chop and change without kind of hard coding the idea that we don't trust Geth particular or whatever else. We've seen on Twitter over the last few days some large stakers turn around and saying we're reviewing our usage of Geth. If 3, 4, 5 of those people turn around tomorrow and said, oh, we're all moving to Nethermind, we're going to have exactly the same problem, but with Nethermind. And it's going to be one of those situations where we have to recognize that our aim is certainly to reduce the supermajority, because that's the critical issue. But then beyond that, it is to bring ourselves down to the state where either we have a very fair share across 4, 5 different execution clients, or we have a system that allows us to look at multiple nodes, multiple different execution clients, and make sure they all agree before we progress.
Absolutely. And hope that there's no weird confluence of spec misinterpretation amongst a multitude of clients such that they might comprise a supermajority. But obviously, the more you spread stake share amongst clients, the less likely something like that is. If you have something lopsided, yes, like 50 plus 20, then it can still happen, right?
Absolutely. Absolutely. So we need to get it down far enough that we hope that the different teams between them have independently built the software out, and all of these bugs get caught. And it can happen, kind of. If we look at the original beacon chain and the spec there, there was an idea that a proposer gets 12.5% of the attestation rewards. Due to a slip up in the code or in the spec, it was a quarter of that roughly, and no one caught it until after the system had released, and all of the beacon nodes were happily following along with that. So absolutely, it can happen, but again, we learn from that type of situation, and we try and make sure that people are much more clean room. One of the other problems of having a supermajority is you tend to use it as a reference. So again, if you go on to Geth and you're on a JSON RPC call against it and it gives you a certain information back, you're going to assume everyone else does the same thing. All the other nodes do the same thing. You're not going to wonder if it's exactly correct or not. You're just going to go ahead and use it. Unfortunately, you will also see the situation where potentially the other node developers will do the same thing. They'll look to the majority client to see what it does, and then they'll copy it. Now, again, we're addressing that. There's the execution APIs as a separate repository coming out. People are trying to define what things should be absent of any client and then get each of the clients to implement it separately. So the more and more that we build these systems in, the more and more that we are spec driven with multiple implementations, as multiple implementations are independent, the lower that likelihood is. But yes, it's always a possibility. Absolutely, and something that we need to protect against. And as we say, once we get our supermajority client down to less than 2/3 of the share, we should be getting it to half of the share, and then we should be trying to get it to an even share along with every other execution node we have out there, because that's the only way that we can be as safe as possible.
Fully agreed. All right, I see one question from Torsten. Vouch uses Dirk for key storage. For someone running another validator client right now, what are good practices or perhaps best practices to move to Vouch? I assume it doesn't integrate with Web3 signer.
Okay, so no, it doesn't integrate with the Web3 signer. Is a nice simple start. So we've talked about Vouch. Dirk is Attestant's key system. So it allows us to store keys and it allows us to manage signing operations. So it provides the anti-slashing features. Traditionally, Dirk is run in a distributed system. So for example, you might have a threshold of you need 3 signatures out of 5 separate servers running Dirk. Only 3 of them need to provide the signature back to Vouch for that signature to be valid. You don't have to run it in that way. So if today you were running, let's say, Web3 signer, then you could install Dirk next to it. You could shut down Web3 signer. You can import the keys into Dirk, and then you can use Dirk instead with Vouch. The format between something like Web3 signer and something like Dirk are ever so slightly different. The various reasons for that, not least of which is that we provide, again, we mentioned earlier optimizations. One of the optimizations we provide is batching. So if you've ever run, for example, the Teku validator client, because I was running that recently, and you put 1,000 keys behind it, you will sit there and watch as it starts up, and it will say, I've done 10 keys, 20 keys, 30 keys, 40 keys, and it will keep going for a while. So it takes a while until it ever gets up and running because you have to decrypt each key individually. If you look at something like Dirk, then it has functionality at the back end where it will batch all of the encryptions together. It will put them, so it'll basically decrypt all the keys individually, put them into a single large encrypted file, and then it will decrypt that one file, which means that startup time is largely independent of the number of keys you're running. So that type of thing can make things a lot faster. But yeah, in terms of moving to Vouch, Vouch only uses Dirk as a back end. And there are all sorts of reasons around that, including historical ones. But one of the things that we've always tried to do is ensure that security is first. And some of the features in and around Web3 Signer, certainly when it provides multiple systems with the same keys on, and then having a sort of centralized database to protect against multiple signings and similar, is not something we're comfortable with. So the reality is in that situation, we would say, yep, you can import your keys from Web3 Signer into Dirk. You can then run Dirk with Vouch behind it, and that will allow you to move over relatively cleanly and relatively easily. Certainly, one of the things that would be very interesting for anyone listening on this call, for those of you who are interested in doing something like that, always happy to sit down and chat. I'm in the Discords, I'm on the Telegram groups. I'm sure most people can find me if they want. Certainly looking at how we can do some of those migrations and making those migrations easier for people is something that we are interested in doing. We recognize that lots of people are out there running staking systems already, not using Vouch. That's fine. But if they want to move over to them, then migration guides are not something that we have today. It's not something that we've been heavily involved with, but certainly, if people are interested in doing those migrations, that will allow us to look at those processes, provide more details, and eventually, ideally, guides to help people migrate over.
Just waiting to see if there's any follow-up questions from Torsten. but it seems like no. I have one more question about something that you brought up during your presentation, with regards to the threshold configuration around attestation consensus, let's say basically for validity of well, not validity of the attestation itself, but whether the attestations are provided by the attached execution layer nodes. Is the threshold relative or absolute? And what do I mean by this? Let's say you have 3 nodes connected and you have a consensus threshold of 2 out of 3. Does it require a minimum of 2 actual responses? Or, for example, actually, this case is not good because if you remove 1, you can never reach that threshold. But what I'm trying to say is if you can get the percentage, but you don't have the actual absolute number of responses, like what does Vouch do in that case? Does it require a minimum amount of actual responses? And therefore, if it doesn't get them, like not a test or not vote at all?
So again, if you set a threshold, that threshold is an absolute number. So and that's critical, right? Because we don't want to be in a situation where we can, because some client has gone down, suddenly, you know, a geth related thing has leapt over the threshold. You know, if geth is the only response, but we want to have 2 responses that match, then we don't want to be in a situation where it's like, well, ideally it would all match, but geth's the only one responding, and so we'll move ahead with geth anyway. So the reason we don't want that, of course, is because if, let's say, there's a situation where you know, Nethermind gets each other node, it gets a bad block, and because of that, it goes into a bit of a tailspin. And again, historically, we've seen this on the consensus side, where when we get into non-finality and similar, nodes get overloaded. If suddenly the other nodes fall over or are unable to respond because they're busy elsewhere, we still want to make sure we get that absolute guarantee. So thresholds are always absolute numbers. And again, it will fail safely as far as we're concerned. You know, if it can't get the threshold it needs, it will not attest. And that's, you know, a very important situation, we believe, that matters. Now, equally, if you don't want that to be the case, then you can just remove the threshold and it'll go with whichever attestation data has been a majority response. And if that is geth, then so be it. So you can certainly have all these different variables and varieties and ways of doing things. And again, it really comes down to the specifics of how you want your system to react in any given situation. As we said, it might not be as simple as we've got a chain split, you know, geth's gone bad or whatever else. It might be, you know, the vast majority of situations are, I have 3 execution nodes and 2 of them are in different data centers and the network's gone a bit flaky. Most of the situations you meet will be far more operational than some major protocol failure. So you need to understand kind of how you want to handle it. And again, it can be different situations. You might have 3 execution nodes all sitting on the same machine as Vouch, in which case you're not worried about network. They might be scattered around the planet, in which case getting a threshold matters. Having a certain timeout matters. So depending on your configuration and architecture, lots and lots of different ways in which you could configure it. And it really then comes down to, again, your own operational decisions as to how you want to act in certain situations.
Awesome. Very, very thorough and lucid as always. Thank you very much, Jim.